The benchmarking paper I'll be talking about today is called AgentArch, which is basically a comprehensive benchmark for evaluating agent architectures in enterprise workflows. And I will explain what that means. But yeah, briefly, I just wanted to go over like a bit of a general background for agentic AI, just so it's clear what I'm talking about. So here, when I talk about agentic AI, I'm basically referring to some kind of autonomous system that can independently perform tasks. So this would involve like perceiving an environment, reasoning about what to do, planning, executing some kind of action, and then reflecting on the outcomes of those actions, and sort of doing that process in a loop to accomplish some specified goal. And when I'm talking about agentic systems here, I'm specifically going to be talking about agentic systems powered by large language models. And then in terms of like the enterprise component here, like a lot of the time what we see is that agentic can be used to automate existing workflows. So for example, if you had a customer service workflow you wanted to be automating, or an HR onboarding or HR hiring, be able to automate those steps using agentic and then basically be able to remove humans from that process as much as possible, is kind of what I'm going to be talking about. So first, I just want to talk about the motivations for this benchmark before I actually get into it. So basically, there are a lot of existing papers and benchmarks that are evaluating various components of agentic systems. So a lot of benchmarks might focus, for example, on tool calling, like how good are LLMs at choosing the right tools or APIs to call. Other benchmarks focus on different orchestration methods. So that might be like, is it better to have like just one single agent that has access to a bunch of tools? Or maybe do you have like different agents where some agents are more responsible for planning or like executing things versus like different setups where agents all have a similar role or highly specialized roles. So that's like another component there. There's also the component of memory handling, which is basically just describing like how do you handle the context that an agent is provided? Do you give like a full complete context that includes like, any other steps and actions previous agents have taken? Do you make it more narrow in scope, focus on just what that agent has done so far? How do you handle those kinds of context limitations, especially when you have like a more long context situation? And the other things that another thing that people have tested are the integration of thinking tools. So basically, these could just be tools that you provide a model that gives it extra space to sort of do some kind of chain of thought reasoning, separate from calling actual tools. But what we found is that in these existing benchmarks, these elements are often evaluated separately. So you might have a benchmark just focused on tool calling or just focused on orchestration. But we don't see that many benchmarks that sort of test these different elements of agentic systems in combination with each other. So if you wanted to know like how would this style of tool calling work with this style of orchestration, it's a bit hard to know from the existing literature and benchmarks. The other thing we find is that like a lot of these benchmarks are not realistic in terms of what an agentic system might look like in real world deployment. So often what we found is that when you're basically trying to use an agentic system to automate an existing workflow, what you might find is that like a lot of these existing workflows might have legacy code, really complex, messy data. Like instead of the tool just returning like an exact response that is relevant, there might be like a complicated JSON with a lot of metadata, and like the relevant information is in there somewhere, but it's not immediately clear. And these existing workflows might also have like very complex rules and steps that need to be followed in a very specific order. And we don't find that these kinds of constraints are represented in the existing benchmarks. So based on those two main gaps, our goal was to develop a comprehensive benchmark that basically tests a bunch of these different components of agentic systems together, and also have this benchmark be tailored to real-world enterprise constraints. So now that I've sort of explained the motivations for the benchmark, I'll just go into talking about how it's set up. So basically, we designed two use cases that are supposed to be representative of existing enterprise workflows. So one is this requesting time off use case, which is basically, if like an employee wants to request PTO, it's supposed to automate that process by retrieving the information about the employee, checking if they're eligible, if they have enough PTO balance, then if they are eligible, submitting that request and deciding if it should be approved or rejected. And so this is the simpler use case that we designed, in that it has fewer tools and fewer agents. And one of the key challenges for this use case is being able to basically reason through date calculations. So if the employee says something like, I want to take time off from February 27th through March 3rd in 2024, the model has to be able to figure out how many days that is, like knowing how many how many days are in a month, different months and leap years and all that. And then basically be able to compare that number to a leave balance to be able to see like, is this valid or not? And then we also have this more complex customer routing use case, which is supposed to mimic like a customer service system. And so one of the key challenges here is basically differentiating between simple requests and complex requests. So if it's like a simple issue that already has a solution, that should be classified and handled in that way. Whereas if it's like a new complex issue, then like a new case might need to be created. So one of the key challenges here is basically making like the appropriate escalation decision and then following the right instructions and steps based on that decision. So now I'll just talk about the other aspect of the benchmark setup, which is the different architectural configurations I mentioned. These are the same four categories I mentioned before, and I'll just explain like the different parts we test. So for orchestration, we wanted to test both single agent and multi-agent systems. I'll explain like the difference between these two in a second. For different agents, we wanted to test both like function calling, where models are basically asked to like respond with like the tool, like the tool and like the inputs parameters for that tool versus React style prompting, where models are asked to first reason and then output their action, action being the tool call here. Then for memory, we basically wanted to test if like models benefit more from a complete memory in terms of seeing like a full conversation history of like everything that's happened prior versus like a summarized setup where they only see a summary of what like earlier agents might have done. And then for thinking tools, we defined two thinking tools, one that's meant for math and one that's called synthesize collected information. So math is pretty straightforward. It's just for like doing math calculations, basically giving the model extra space to output those tokens to do that reasoning for doing a math problem. And then synthesize collected information would basically, the intention there is it can be used if like the model has collected a bunch of information through tool calls and now needs to decide like what the final decision should be. So giving it space to reason through that process. Yeah, and then going back to orchestration for multi-agent, we have two separate setups. So in both cases, there's an orchestrator, which is given the initial request, and then it picks agents. And agents have access to certain sets of tools. So an open agent network, once an orchestrator gives the task to an agent, let's say that agent needs some help, it can't proceed without some information, it can then ask another agent directly, and then that agent can call its tool and return that information. Versus in an isolated agent scenario, if the agent gets stuck, it will ask the orchestrator for help, and the orchestrator selects which agent would be best. And that's the process there. But basically with multi-agent, there's an orchestrator that's given the task, it selects agents, and agents call their own tools. Versus in single agent, there's just one agent that has access to all the tools in the use case, and it sort of decides what tool to call next. So now that I've sort of just given an overview of how the benchmark is designed, I'm going to go into describing some of the key findings, and then after that, sort of explain in more detail the methodology that we use to get to those findings. So I'll explain this acceptable metric here later, but basically what you can see here is all the different configurations we've tested. So for the orchestration, each agent, then each memory option, then thinking tools enabled or disabled, and the scores that each model got on each use case. And in this case, larger numbers and darker cells indicate like higher performance. And so there's a couple of key takeaways that I want to describe. The first is that like the models overall are still struggling with these use cases that we've defined. As you can see, like the highest score on the simpler time off use case is 70.8. And for the more complex customer service use case, it's 35. The other key thing to see here is that there's no single configuration that works for every model or every use case. Like even just like quickly looking at like, the color to see how dark it is, you can see that like it's not the same for each model. Like for example, GPT-4.1 is like doing much better on single agent versus like for some other models like GPT-4.1 mini, it's doing better on this orchestration multi-agent setup. So like looking more closely, you can see that there's just like not a lot of consistency in terms of what configuration works. The other thing to point out is that it also depends on the use case. So for example, if we look at Sonnet 4, you can see that for the customer service use case, the highest scores were all on single agent function calling setups, but that is not the case for the time off use case, where you can also see pretty similarly high scores um, on several different configurations. Another thing we see is that especially for the non-reasoning models, thinking tools can often enhance performance, especially on this time off task, which as I mentioned involves those like date calculations. So if you can see here, like the only difference between these bottom two rows for GPT-4.1 single agent is the thinking tools were enabled or disabled. And you can see like a much higher score for enabled versus disabled. And so for certain models, we do see these like pretty big differences when thinking tools are enabled. And then the other thing to note is that we often find that function calling as like the agent style tends to outperform React prompting, especially on the multi-agent systems. So like if you look for GPT-4.1, you can see there's the function calling numbers versus above the React numbers are generally lower. You see especially the same thing for GPT-4.1 mini, GPT-4o, and even here for Sonnet. Okay, so now that we're going to look at a different metric, which is a hallucination metric. And here we're defining hallucination as basically the model trying to call a tool or an agent that doesn't exist or with parameters that are hallucinated values. And the really interesting thing is, as you can see, like hallucinations are much more common and almost exclusively found for certain models with React prompting in multi-agent systems. Like for certain models like Sonnet, it's like really extreme where we found not a single hallucination in any other setup except these multi-agent React scenarios. And you can see for some models like O3 Mini, it's like a really high percentage because this just refers to like the number of tasks within the use case where any hallucination was present. Another key finding is related to the correct final decision. So in this case, when I'm talking about correct final decision, this just sort of means the final choice that is made at the end of a workflow. So for example, with the time off workflow, that's just like either the leave request is approved or rejected. And for customer service, either a new case is created or it's not. And so this looks at just like how often is that final choice correct. What we find that is interesting here is that for certain models, it's much higher in multi-agent setups. So for a multi-agent setup, the orchestrator at the end is the one that basically reflects on all the results of the tool calls that agents have made to make this decision. And you can see that for certain models, this correct final decision metric is much higher for some of the multi-agent setups compared to the same setups, except with single agent. And this is especially true in the customer service use case. So this is just a brief summary of what I've discussed.
Tara, just a quick question. Someone says
Yeah,
that they missed the distinction between TO and CR.
yeah, sure. Can go back to that. Yeah, sorry. So this is these are abbreviations we're using just to refer to these two different use cases. So TO is the requesting time off for PTO eligibility, and CR is the customer request routing for mimicking a customer service system. So this one has fewer tools, this one has more tools and more agents, and more instructions and steps. Does that clarify it?
Yeah.
Cool. Yeah, so in each of these charts, those are what these two things are referring to. Yeah, so just to reiterate, key findings were that models are still struggling with these complex enterprise workflows. Preferences vary a lot by model and use case. There's no single architecture that works for all models or for all models on a certain use case. We find that thinking tools enhance performance, particularly for non-reasoning models on tasks that require computation or calculations. We generally find that function calling outperforms React prompting, especially in multi-agent systems, and that hallucinations occur much more frequently with React, especially in multi-agent systems. But as mentioned, for the final decision, we do find that multi-agent setups yield higher accuracy in that final decision metric, despite sometimes having a lower overall score. And then past power K, I will discuss a little bit later. So now just to go over the methodology for how we created the benchmark and this data and metrics. So for each use case, there are 60 separate tasks, which have been annotated with the ground truth for expected tool calls, expected tool inputs, and expected final outcome. And then for metrics, we wanted to have a acceptable metric that really reflected what success looks like in like a real world agentic system. So for example, like the correct conclusion is not enough for a successful execution. So for example, even if like a leave approval request is meant to be accepted, and it is, it's not really successful unless it's also followed the whole process along the way in terms of like notifying the employee, notifying the manager, and calling the tools with the correct parameters to reach that correct final decision. So for that reason, we define our overall acceptable rate as all the cases where the tool choice was correct and the tool arguments were correct and the final decision was correct. And then we measure this over K trials where K was set to 8 and also compute pass power K, which is the probability of passing all K trials, which is important for reliability. What we find there is that this pass power K score is very low, indicating a lack of reliability and consistency, which is particularly relevant for enterprise deployments where you can't really deploy a system if it's not going to be successful most of the time. So then finally, I was just going to talk about the limitations of this benchmark and future work that we'd like to do. So one of the key limitations is that it has a very narrow scope right now. There's only two use cases with 60 samples each, which makes it kind of hard to generalize as to like what would happen on different types of use cases, more complex ones. So that's definitely something we'd like to add in the future as more use cases to represent a larger variety of enterprise workflows. We're not able to evaluate that many models currently. Particularly, we only had one reasoning model, and it would be really great to add more reasoning models just so we can see if the trends we saw for reasoning model for on O3 Mini specifically generalized to other reasoning models. The other thing is that we use like deterministic tool responses that like return mock data, which might not reflect real world variability in tool execution. So it's another key limitation. So in the future, we definitely want to expand use cases and model coverage, and also potentially create a new benchmark or add to this one that has a multimodal component. So if the data could contain either audio or images, that would also, I think, make it more realistic in terms of the direction that agentic is going in terms of having that multimodal component. And then we also had a lot of interesting key findings related to multi-agent systems, especially around like the React style prompting within multi-agent systems. So it would be interesting to do a deeper analysis of that and maybe have more focus on specifically that scenario to say like why are we seeing those kinds of scores in multi-agent systems. But yeah, I think that's pretty much it. Any questions?
Great. Yeah. So I guess, yeah, we'll move on to questions. So yeah, I'll just be going through some in the chat. I'll read them out and then you can answer them. So this first one from Keith. The problem is always the objective function under ambiguity, hence the focus on math and coding for verifiability under binary epistemics. You can observe all you want, but without the goalposts of acceptability clearly established by all, you just have ad hoc patchworks and are right back where you started. LM as judge works great, but the judgment criteria is always the issue. And I think just so everyone can understand what Keith is saying, I think what he's saying is that um, it's the difficulty in the task lies in determining what is the correct behavior, not in like just configuring an evaluation. So yeah, Tara, you can respond.
Yeah, sorry, could you just repeat the final part of that question?
Like what I said or what the Keith's question
Keith's question, sorry.
is. So he's you can also see it in the chat, but he said
Oh, okay.
LLM as judge works great, but the judgment criteria is always the issue. Like, how do you actually judge whether, like, what is the criteria for an agent being successful?
Yeah, this is a great question. So we didn't actually use LLM as a judge here. And I think basically because we define these very specific scoped workflows, you can create like an exact ground truth. So for example, if we know what each tool will return, then we can say, okay, like we know what the model should choose at each step. If it has instructions to follow these steps, call these tools basically, and we know what each tool will return, we can basically then say for sure what the expected outcome is for each of those steps. So this is like I think part of the reason why the benchmark is sort of narrow in terms of the amount of data we have is because they were each record contains both like exact tool responses that are mocked and an exact pathway that we expect to find in the ideal scenario.
Cool. So, you would say that th this benchmark is well suited for agents that have like systematically verifiable like outputs, like whether it's correct or
Yeah,
not is like something, yeah, something you can evaluate based on, yeah, whether like the correct tool was called or yeah, like the final answer.
exactly. So that's what we were trying to do here is just have something very specific like that. So that's part of the limitation that doesn't always generalize to
Hmm.
other cases where you don't have that, but in these cases we do.
Yeah, no, yeah, that makes a lot of sense. So another question, kind of similar. Dipanshu asks, how would you validate the PTO workflow? Like, would you need to create ground truth manually? I guess asking specifically about what a correct action by that PTO like agent would look like.
Yeah, for sure. So a correct action would basically look like um, the steps would be that the model retrieves the user information correctly using the information that was provided in the request. It then is able to calculate the amount of days that the user has requested, which is sort of around the example I gave before. Like if the request is given a natural language, right? So if I say like, January 4th to February 2nd, does it correctly calculate that number of days? Then it would be, does it retrieve the balance correctly? Does it make the comparison correctly? So for example, the instructions say like, if the leave request amount is greater than the balance, reject it. Otherwise, proceed with this step. Um, and so that's kind of the flow that it looks like, is like basically it checks like if there's enough balance, if there's any conflicting leave requests, if there's any pending leave requests that could affect the balance, and then based on that, it either makes a decision to accept it or reject it. And so correct looks basic would look like if the request is not valid either because of the balance, pending leaves, or conflicts, it's rejected. And if it is, it's accepted.
Yeah, that makes a lot of sense. Another question, a few people are asking for multi-agent versus single agent, why one performed better than the other, asking for like more, you have like a reason for why for the findings you saw and the comparison of those two.
Yeah, for sure. I think one thing we found, I can go back here, um, is that one thing to note is that I think for this simpler use case, when there's only 8 tools, it might be the case that multi-agent just isn't as necessary. I think sometimes what people have found is that multi-agent setups are really helpful when you have like a much bigger scope for a workflow or for a use case. For example, if there's like, 20 agents and each of them have up to 20 tools, that's just too much information sometimes to give to one model in one prompt and expect it to basically filter out the irrelevant tools and get to the right choice. So it's also possible that in this like um, simpler use case, it's just not maybe as reflective of when it's helpful to have multi-agent systems. I think the other reason what we see for the final decision, I think the reason we see a difference there is because having this orchestrator planning agent, also which basically also does like a reflection kind of component at the end, kind of provides like an extra verification step of like now that we've collected this information, like there's an extra step where the orchestrator agent is like, okay, what is the final decision? Um, so I think that part of the setup might be why you see this correct final decision being higher for this orchestration setup. I think another thing in terms of why React underperformed is that we were basically using React prompting both for the orchestrator to select the agents and also for agents to select tools. So I think one thing that we could investigate in the future would be if we separate those two things as separate components. So for example, like some situation where we don't use React for the orchestration step, but only for the agents calling tools and multi-agent setups, if that has differences. But yeah, I think one difference we also see in terms of multi-agent React is that I think the hallucinations are often due to sort of confusion around the existence of other agents I think sometimes like one thing I saw in traces would be like that for certain models they didn't understand basically that like the other agent's tool calls are also valid because they don't have access to those tools. So if the prompt is saying like you have these tools, but the conversation history indicates the existence of other tools by other agents, that sometimes led to confusion.
Yeah, that makes a lot of sense. Yeah, I think multi-agent systems just adds a level of complexity that sometimes like LLMs are like not, like very robust to that. But yeah. Some more questions. Dipanshu wants to know, is asking, could you share some production use cases of agentic systems at ServiceNow?
Yeah, I think one example would be this kind of customer request routing. Another example, um, I'm trying to think what else we've seen. Yeah, I think that's probably the best example is something very similar to this customer service request routing in terms of basically auto creating incidents, as we call them at ServiceNow, routing to the right place, assigning to the right groups, assigning defects, that kind of thing.
Yeah, I think just like one other I've seen it kind of in this area is like IT ticket
Yes.
sort of response. Yeah, so that's another one.
Anti-ticket like response and
Mhm.
processing. Yeah, it's another good
Yeah.
one.
Cool. Yeah, so a couple more to wrap up. Uh Alberto is asking to avoid the use of LLM as judge, is the verifiability of the expected outcomes produced by the different tools or LLM calls achieved by leveraging very constrained pydantic schemas or something else?
Yeah, so that's part of it. Like I think for like the um in terms of checking that like the tools exist and the parameters are valid, that is achieved in that way. Um, and then yeah, we just do a lot of exact match comparison for like tool names, argument values, that kind of thing.
Cool. Yeah. Another question. If you would have to pick one model today for a single agent type application, which one would you choose? And cost is not a factor.
Yeah, it's an interesting question. We can look back over here. Um, Yeah, one thing to know is that I think because of the timing of this benchmark and when we created it, a lot of models have been released since then. So like GPT-5 is not included here. Sonnet 4.5 has not been included here. And so I think that would definitely potentially make a difference is being able to see those numbers. But I think one thing that I find interesting is that I think what would make a difference if I had to select just one model is looking at the single agent performance over both use cases, in which case, like just looking at these models, I would pick Sonnet 4 because as you can see, it performed its best on the more complex customer service routing with single agent. And, it performed pretty strongly on the requesting time off use case as well with single agent. I think not the objectively highest score, but it definitely achieved similar scores. I think that's kind of what I would look at is if you had to pick just one architecture, is looking at how does that architecture perform with both use cases. And that's another key takeaway here is that like sometimes depending on the differences in use cases and also like what is most important to you in a use case and what is most important to success, you might want to pick different architectures um, or different models depending on how they perform across both of those. Does that make sense?
Yeah. Cool. So there's a few more questions, but we're a little over time. If Tara, if you want to, share like some contact information so people can reach out to you, up to you, obviously.
Yeah, for sure. I can share my email in the chat.
Cool. Yeah, so yeah, feel free to ask any questions there. And yeah, thanks everyone for coming. And see you guys maybe in the next time.